Swayam Prabha. Digital India. Educated India.
Namaste and welcome back to the video course on watershed management. In module number 7 on management of water quality, today in lecture number 28, we will discuss about groundwater pollution problems and transport processes. So, some of the important topics covered today include groundwater pollution sources, pollution control, groundwater pollution remediation, transport processes in surface and groundwater. Some of the keywords for today's lecture: groundwater pollution, control, remediation and transport processes. So, as we discussed earlier, so when we deal with the water management, say within a watershed, we have to deal with the surface water and the groundwater. So, it is not only the quantity of water what is to be made available to the flora and fauna or to the people within the watershed, we have to see the quality of the water. So, as we discussed in the previous lecture, the water quality is a major issue, surface water quality as well as groundwater quality are major issues which we have to deal nowadays. So, due to various reasons, the quality of groundwater or surface water have deteriorated very much. So, in today's lecture, we will see the problems related to the groundwater quality. In the last lecture, we have discussed about the surface water quality issues. So, when we deal with watershed management, so groundwater is a major component of the as far as water resource is concerned. Groundwater is a part of the hydrological processes which we have already considered. So, with respect to the infiltration and then the water is joining to the water table or the aquifer systems, and then that will be interacting within the systems. So, that way whatever is happening within the surface, if any pollution source is there within the surface of the planet or within the surface of the watershed, then that will be also affected to the not only to the surface water, but to the groundwater also. So, that way when we deal with the watershed management, the groundwater quality is also a major issue. So, groundwater assessment we have to do with respect to the quantity, and then also we have to do the monitoring of the water quality. So, this as we discussed in the previous lecture, the water is concerned, we have to see the way how how much pollution is there within the water, or whether any the water quality meets certain standards for various purposes like drinking purpose, irrigation purpose or domestic purposes. So, like that we have to see whether the available water quality is safe for the proposed use. So, that way depending upon the use of water, say the physical, chemical and microbiological analysis of water we have to do. So, as we discussed in the last lecture also. So, physical analysis, chemical analysis and microbiological analysis to see that the water quality standards are met. So, as far as groundwater is concerned, say very similar to the surface water, since both the surface water and groundwater are interacting within the hydrological processes. So, some of the pollutant source include toxicity like micropollutants and other industry pollutants, then pathogenic pollutions, then salinity problems. So, like that these are some of the common issues as far as groundwater quality is concerned. So, now let us look into the detailed aspects of groundwater say related quality related problems. So, the problems with the groundwater as we discussed in earlier lecture also, say some locations of the planet of the earth, say people are using too much groundwater, so that way overdraft is some of the issue, so that the water table is going down. And then say the issues related to mining, say especially say when the mining operation, lot of wastewater is produced, and that is say polluting the aquifer systems or the groundwater systems. Then subsidence, then like water logging problems, say wherever the water table is rises to certain, say beyond certain level, then water logging and its related problems related to agriculture and other areas. And then coastal aquifers problems like seawater intrusion. So, the salt water mixes with the pure groundwater, and then that is say the groundwater become useless, or we cannot utilize for the purpose which we are looking for. So, that way groundwater pollution has become a major concern in the last few decades throughout the world. So, that way say nowadays the hydrologists or groundwater hydrologists, we are always thinking say how we can preserve or conserve the existing groundwater source, which is always the annual basis it is recharged due to the rainfall and other sources. So, we have to conserve and preserve so that the water quality standards are met for either for drinking or any other purposes which we are looking for. So, say the last few decades due to the industrialization and various other human made problems, the groundwater resource has been say assaulted in different ways, and then the quality of the groundwater in many locations have gone down. So, the groundwater quality is very much deteriorated due to rapid industrialization and human mismanagement. So, we can call this as human mismanagement. It is not happening due to the natural causes mainly, but due to the human interventions within the system, and then it is not appropriately done. So, that are some of the major reasons as far as the deterioration of the groundwater is concerned. So, when we deal with the groundwater, say as we discussed earlier also, the management of groundwater systems is concerned, we have to deal with the quantity of the groundwater and the quality of the groundwater. So, as far as quantity is concerned, the total volume that may be withdrawn annually from the aquifer. So, we have to see that there is a balance between what is recharged and what is withdrawn from the aquifer systems. So, that the groundwater table will not say go down drastically. And then the location of pumping and artificial recharge wells and their rates. So, say if you consider an aquifer system, say depending upon the recharge rates, how much we can pump out of the aquifer systems, or if you are going for recharging, say how much we have to recharge with respect to the available water. So, all these things we have to say deal effectively for groundwater management. So, we have to take certain decisions as far as the groundwater quantity is concerned and also groundwater quality is concerned. So, as I mentioned, even if the sufficient quantity is available, if the quality of the groundwater is not good, then we cannot use for the purpose which it is meant for. So, we have to take decisions related to groundwater quality. So, groundwater contamination, as I mentioned, can be due to various sources like hazardous industrial waste, leachate from landfills, agricultural activities such as the use of fertilizers and pesticides. So, as we discussed in the last lecture, these kinds of pollutions can be either point source pollutions or the non-point source pollutions. So, point source is directly what is coming from just like say from underground tanks, if a leakage takes place and that is going to the aquifer systems or the groundwater is affected, that is point source. But non-point source like say agricultural sources, say like nutrients or herbicides or pesticides, these kinds of pollutions are non-point source of pollutions. So, we have to deal the groundwater systems effectively. So, we have to that way we have to say that groundwater systems to be managed effectively as far as quantity and quality are concerned. So, management means making decisions to achieve goals without violating specified constraints. So, this say when we are looking say for example, from a given aquifer, if we want to pump out 1000 meter cube per day. So, we have to see that the objective is to meet that 1000 meter cube per day, but we have to see that certain constraints, say like the groundwater level should not fall below certain specified limits, or say the quality of the groundwater should be good enough with respect to whether for the standards say for the drinking water or the agriculture purposes. So, that should be met. So, we have to see that specified constraints are met. So, good management requires information on the response of the managed systems to the proposed activities. So, here that means the aquifer systems or groundwater systems. So, if we are pumping this much water, what happens, or if the quality, so if a contamination is going through the system, the groundwater system, how it is spreading and what will be the effects. So, this information enables decision maker to compare alternatives and ensure that constraints are not violated. So, say for example, if there is a pollutant source to the aquifer systems, so and then if pumping the water is pumped for drinking drinking purpose or water supply purpose from that aquifer system, then how say whether there is will be an interaction. So, how we can manage this, so the pollution source or the plume. So, the decision maker has to take a decision by considering various options like groundwater modeling or groundwater pollutant modeling or contaminant transport modeling. So, any planning of mitigation or control measures once contamination has been detected requires the prediction of the path and the fate of the contaminants in response to the planned activities. So, like you say, if we are going for say the control measures, so we have to see that say the how much portion of the groundwater system is affected, or how where the plume is moving and how what rate it is moving, and whether that will reach the pumping well which we are say we are pumping the water for water supply or other purposes. So, all these issues we have to see. So, any monitoring or observation network must be based on the anticipated behavior of the system. So, we can through groundwater modeling we can identify the anticipated behavior of the system. So, then if we are having a monitoring or observation network, so through that we can identify what is the best way we can manage the groundwater systems as far as the groundwater pollution is concerned. So, now say what we are discussing is related to groundwater system management with respect to quantity or quality. So, now let us go into the details of groundwater pollution sources and then pollution control and the remediation aspects. So, groundwater pollution problems. So, as I mentioned say when we are dealing with the water resource in a watershed, so we have to see that not only that sufficient quantity of water is available, but quality is also good enough. So, the water is useful only if quality is safe. So, that is very important aspect. So, quality is indicated by say as we discussed in the previous lecture the various indicators like dissolved or suspended solids, or the whether the water is basic or acidic, say like a pH indicator, or say the biological quality, so like that. So, then say when we discuss say on a watershed basis or a river basins basis or aquifer basis, we have to see what are the important sources of pollution. And then we have to see what are the important forms of pollutions, whether it is the form is dissolved salts or domestic or industrial waste, or whether heat pollution or radioactive materials, pesticides, manures, etc. So, what is the source of pollution, and what kind of pollution is there, what is the form of pollution, and then how the pollutant or the contamination is moving within the aquifer system. So, pollutant transport or solute transport say generally takes place with the flowing water. So, in the aquifer system, the groundwater is moving from one location to another location according to the hydraulic gradients and other parameters. So, we have to see that how the solute is transported. So, various processes as we discussed earlier also, processes like a convection, hydrodynamic dispersions, all these controls the groundwater pollutant movement or the contamination movement within the aquifer systems. So, groundwater pollution issues, when we discuss about the various issues related to groundwater pollution, we have to see some of the important things like pollution sources, then pollutant movements or contaminant movements, then how we can control the movement of the plume or contamination, and then how we can protect the groundwater systems, and then wherever it is polluted, how we can say remediate it, so that we can retrieve back even though it is not to the original system, original quality, but to certain extent we can remediate it. So, what kind of remediation are possible. So, all these issues we have to consider. So, groundwater pollution issues include source identification, then we have to identify where the contamination is moving or movement of the contaminant, then control and protection, and then pollution remediation. So, these are some of the important issues which we have to consider when we deal with the groundwater pollution. So, now let us look into the important sources of pollution. So, groundwater contamination sources. So, here some of the important contaminant sources I have listed, like natural contamination, agricultural contamination, industrial contamination, underground storage tanks, land application and mining, septic tanks, waste disposal injection wells, landfills, etc. So, if this is the watershed or which the area which we are considering, so there can be like if farms are there, then non buoyant source of pollutions, and then if septic tank or the landfills. So, it will be seeping with respect to rainfall, the contamination will be seeping down, and then that will be joining the surface water or to the groundwater. So, that way various sources of pollutions are possible. So, we have to identify what are the important sources of pollution, and then we have to deal with the corresponding source, say to control the pollution and then for remediation. So, now let us look into various aspects of this groundwater pollution sources. So, as I mentioned, the important source of pollutions already we have discussed. So, first one is the domestic waste. So, domestic waste can be like household waste, septic tanks, liquid fraction from septic tank pollutes groundwater, then inefficient design increases pollution. So, like say especially household waste, especially the sewage water coming from the house, say so that you can say most of the time it will be directly draining to the either to the surface water or the say the drainage systems. So, that can mix say that can penetrate down or infiltrate down to the aquifer system. So, that way domestic waste can be a source, and then say where septic tanks are there, that can be the leakage related to septic tanks. So, that can create that can be a source of pollution. Then agriculture pollution, as we discussed in the previous lecture also. So, like artificial manure or fertilizers, pesticides, herbicides, then nitrate pollution, then eutrophications, health problems. So, say in drinking water long term problems like say the nitrates and all those kinds of pollutants are long term source of pollution. Then pesticides, insecticides, herbicides, fungicides, all these things beneficial to farming causes serious threat to the surface water and the groundwater. So, once it is the surface water is polluted, that will be interacting with the groundwater systems, and then that will become a source of pollution. So, generally agricultural pollution is concerned, it can be non buoyant source of pollution. Then especially in urban areas, say as far as the solid waste is concerned, say most of the say cities or towns uses say landfills. So, the solid waste will be collected in trucks and then deposited in landfills. So, if the landfills are not scientifically done and then proper measures are not taken, then say this say from the landfill a liquid called leachate, which is produced due to when this rainwater mixes with the contaminant source within the landfill. So, that can penetrate down to the aquifer systems or the groundwater systems, and then that can be a source of pollutions. So, the third one is leachates from landfills. So, it is one of the commonly used cheapest solution as far as solid waste is concerned, and then it can be say for domestic related or commercial or industrial. So, this polluting liquids called leachates is a major source of pollution as far as the groundwater system is concerned. Then the next major source is industrial pollution. So, industrial sources like petrochemical industries, pharmaceutical industries. So, all these produces complex organic waste like non-aqueous phase liquids, it can be dense or light, then spills or leaks from tanks, pipelines. So, all these causes say these pollutant sources either directly coming in say on the soil surface that can penetrate down or infiltrate down to the aquifer systems, and then it can be source of pollution to the groundwater systems, or wherever surface water pollution is there, when surface and groundwater interaction takes place, that become a source of groundwater pollution. Say for example, in Germany it is identified that it is about 240,000 non-aqueous phase liquid contaminated sites identified at various industrial sites. Say for example, Germany is concerned. So, that way this industrial pollution is a major source of pollution. Then say the contaminated land and urban pollution. So, effect of industrial revolution like waste disposed in land around urban areas. So, example mining and foundry waste, tars, oils, phenols, etc. So, these all say are sources of pollution as far as the subsurface water or groundwater. Say for example, in United Kingdom, it is identified that about 500 square kilometer of land is polluted, that means its soil is polluted. So, in about 50,000 sites. So, this say whenever say the water with respect to rainfall, the runoff, and then this water mixes with say interact with these sites, then the contaminations will be say formed as a plume, and that will be moving through the subsurface or the subsurface water, and that will be becoming a source of pollution as far as the groundwater is concerned. And then mining and seawater intrusion pollution. So, water draining from mines, like the nature of this water will be acids, sulfates. So, lot of pollution will be there, acidic or sulfates pollution, iron pollution, cyanides, etc. So, this will be in solution. This pollutes surface and groundwater, and that become a source of pollution as far as groundwater is concerned. And so, abandoned mines are a major threat say as far as the groundwater is concerned. Then as I mentioned, seawater intrusion, so excessive pumping in coastal aquifers. So, that way the seawater intrude to the coastal aquifers, and then that mixes with the groundwater in the coastal regions, and that become a source of pollution. So, we have to look so that the overdraft of groundwater should not be allowed in coastal areas, coastal aquifers. So, proper management measures should be adopted. Then dissolved salts and minerals like arsenic contamination, say in Bengal basins. So, this arsenic contamination, it is actually caused due to overdrafting of the groundwater. So, due to that say certain say minerals or certain salts within the soil say leach, and that become a source of pollution. So, dissolved salts and minerals are also another source of pollution. So, now let us look say into what is the mechanism that is happening say as far as groundwater contamination is concerned. So, we have seen various sources of pollution. So, say for example, as shown in this figure, so if the landfill is there and leachate is there, so with respect to the movement of the groundwater, so this contaminant plume is moving. So, the changes in chemical concentration occurs in groundwater system by 4 distinct processes. Mainly the advective transport. So, that means the when the groundwater is moving with respect to the movement of the groundwater, the contaminants like dissolved chemicals are moving with the groundwater flow. Then hydrodynamic dispersion. So, mechanical, hydraulic or molecular and ionic diffusion. So, various intermixing within the pores takes place, and then say the diffusion, dispersion, all this process taking place. So, hydrodynamic dispersion is another important mechanism of the pollutant movements or plume movements. Then fluid sources like water of one composition is introduced into and mixed with water of different composition. So, say if we are keeping the say some kinds of oils or other kinds of chemicals in a tank in underground. So, that may mix with say if there due to any leakage, that can mix. So, fluid sources also can be say that will say under certain pressures, this will be moving through the aquifer system. So, water of one composition is introduced into and mixed with water of different composition. So, all the polluted water from the surface water, that can be also another source as far as the groundwater is concerned. So, that is fluid sources. Then reactions. Some amount of a particular dissolved chemical species may be added or removed from groundwater as a result of chemical, biological and physical reactions in the water or between the water and the solid aquifer materials. So, whatever the contamination is there within the aquifer systems, so that can change its phase due to various reactions between the chemicals, say like say the radioactive pollutant material. So, after some time, say the material become another phase, or multi phase liquids movement. So, that may interact, and then say various kinds kinds of say chemicals can interact and due to reactions, so say the nature of the contamination itself can change. So, that way as far as groundwater contamination mechanisms are concerned, important mechanisms are advective transport, hydrodynamic dispersion, fluid sources and reactions. So, related to this transport process we will be discussing later in details in this lecture itself. So, now say what we discussed is we have seen the groundwater pollution sources, and then what is the mechanism of this plume movement or contamination spreading. So, now how we can protect the groundwater or how we can control the pollution. So, let us look briefly into various pollution control measures. So, once aquifers are contaminated, it is very difficult to restore, it is a very expensive process. So, it is always sensible to prevent the pollution. So, vulnerability of pollution depends on aquifer nature, like the hydraulic conductivity, what kind of soil is there and what type of contamination is there. So, there are many parameters depending upon which the vulnerability may be serious or mild vulnerability. So, flow speed and unsaturated thickness and all these things. So, we can prepare vulnerability maps showing possibility of aquifer contamination. Say for example, if there is an industry or if there is a source of pollution is identified. So, then for that particular aquifer systems or particular area, particular watershed, we can prepare vulnerability maps. So, say within this many days, say this is the area which may be polluted, or due to if this kinds of leakage takes place, these are the possibilities. So, like that we can have vulnerability maps. Actually, in many countries like United States of America and European countries like Germany, Netherlands, United Kingdom, these countries have prepared such kinds of vulnerability maps, since in many of these countries groundwater is one of the important source of water supply. So, that way to protect this groundwater, so they have prepared the groundwater vulnerability maps. So, from these maps we can identify whether this particular aquifer system is vulnerable, and then what kind of measures can be taken to protect the groundwater as a resource. So, then say we have seen that various sources of contamination is there. So, if we can control the source itself through various strategies, then we can reduce the scope of groundwater pollution. So, let us look into some aspects of source of control strategies. So, to minimize or prevent pollution before contamination. So, this is the main aim of the source control strategies. So, volume of waste is reduced or threat due to waste is reduced. So, whatever the either solid waste or liquid waste, we can reduce it so that the vulnerability is reduced. So, this is mostly applicable in new sites, say, but in older sites we can reduce the abatements, the spreading can be reduced. So, the source control strategies depends upon say the hydrogeological parameters of the site, then how much area is spreaded, the situation, and what kind of contaminant plume or type of waste. So, depending upon that we can adopt typical type of source control strategies, say like to minimize the pollution or to protect the systems. So, some of the advantages of the source control strategies include say it reduces the threat to the groundwater pollution, accelerates time for stabilization of waste disposal. Some of the disadvantages include increased capital and maintenance costs, since we have to spend money to control this source, so that that will not be further spreading to the aquifer systems or to the groundwater system. And then also we have to go for monitoring of the whether say once it is the source is controlled, whether any possibility of further leakage or further movement or the contamination. So, we have to monitor the system with the skilled operators. So, these are some of the disadvantages. Then another model which is tested in many of the European countries and in US include the source protection zones. So, here in the slides, so you can see that say if this is the total catchment of the aquifer systems where the groundwater is pumped for various purposes. Actually we can have protections of individual groundwater sources, say like if particular well is there or boreholes or springs. So, we can go for protection measures. So, we can define the protection zones, say like as I mentioned what is done in United Kingdom, USA, Germany, etc. Around the sources. So, if this is the pumping wells, so we can have generally 3 types of protection zones. The first zone is, this is the first zone, say generally in this countries, say for example 50 days of travel time of the water, say one particular water to reach this well 50 days. So, that we can delineate this zone, and then absolutely no kinds of say any kind of pollutant or industrial activities or any activities not allowed in these zones, so that the water pumped from this area is protected. So, that is zone 1. Then zone 2 is actually the area where 400 days of travel time for the water particles. So, there only the various activities are allowed in a controlled way, so that there is no scope for groundwater pollution to the to that area. And then the last one is the zone 3, where entire catchment itself we can say wherever, especially if the water is used for drinking or for the water supply purpose, then say we can declare that in this zone say certain kinds of activities, say certain pollutant causing industries can be stopped. So, as I mentioned we can have 3 zones, and then we can have within these protection zones pollution activities prohibited or restricted, say zone 1, zone 2 or zone 3 as discussed. As far as the contamination is concerned, so we can go for stabilization or solidification strategies. So, in this say pollution control strategies, we can isolate the waste material in a solid matrix before land filling, say for example. So, the stabilization solidification strategies are very effectively used in many countries. Then these kinds of say methodologies are popular for hazardous and radioactive waste disposal, say especially radioactive waste. Say we can isolate and then put it in a concrete vault and then put it in a very deep say rocky area underground, so that there is no scope for any kind of pollution. And then so also we can chemically fix the waste in a solid matrix. So, if the say particular type of contamination is say if it is possible to mix with certain other chemicals, so that material become inert, so that there is no source of pollution. So, that process is called chemically fix the waste in a solid matrix. Then important stabilization or solidification processes include like cement adding, addition of lime or pozzolanic materials, embedding waste in thermoplastic materials like bitumen or paraffin, etc. Then addition of organic polyester, encapsulation in inert coating, glass formation of waste with silica, etc. So, there are number of techniques say for stabilization or solidification. So, depending upon the contamination material or pollutant source, we can go for specified stabilization or solidification strategies, and then that way we can control the pollutant source, so that the groundwater can be protected. Then another commonly used technique is called hydraulic control. So, here say as shown in this slide, so we are manipulating the subsurface hydraulic gradient through pumping or recharge. Say for example, if this is the contaminant plume, and here if there are certain wells pumping the water for water supply, then say we restrict this the movement of this contaminant plume towards the pumping well through say certain pumping or recharging at various locations. So, that process is called hydraulic control or through well systems. So, this is actually plume management. So, we control the movement of water phase and then hence plume. So, the plume movement is controlled. So, generally 3 common classes of well systems are used, like withdrawal through shallow systems, deep systems and then injection of water. So, we can either through pumping of the water or injection, so that appropriate hydraulic gradient is generated within the aquifer system, so that this contaminant plume movement is restricted. It will not go to the nearby area of the pumping well, but its movement will be restricted. So, here actually this is one of the most assured system, and there should be a good understanding of the systems through groundwater simulation and aquifer characterization. So, the demerit is high operational maintenance cost, since we have to either pump water or recharge, and then continuous monitoring is required. So, this methodology is called hydraulic control or so called well systems. Then some other techniques like surface water control, capping and linears. So, these are also used in many countries for the groundwater protection or groundwater pollution control. So, surface water control and capping and linears used in conjunction each other. So, what we do, say the surface water which is polluted, we can control its movement, and then we can give certain capping or lining, so that this contaminated water is not moving to the aquifer systems. And then another one is surface water control, where we can construct certain diversion dams or drainage ditches, etc., so that the polluted water is not mixing to the aquifer systems. So, this minimize the amount of water flowing into a site, reducing the amount of infiltration. Then say we can go for capping, so that the area is capped, so that further contamination is not taking place or the plume movement is restricted. Then we can also go for impermeable linears, so which inhibit downward flow of low quality leachate or pollutant by adsorption process. So, we can have a certain impermeable linears using clay or other materials, so that will not say the contaminant plume or contaminant source will not reach the pure water source or the aquifer systems. So, all these are used as preventive measures, so that we can control the pollutant movement and then we can protect the aquifer systems or the groundwater systems. So, again further say some of the other techniques used is like sheet piling, then grouting and slurry walls. So, here this sheet piling involves driving lengths of steel or concrete or timber that connect together a thin impermeable barrier to flow. So, this is effective and economic, and piles can be reused. So, we can control the movement of the pollutant. Then grouting means injecting a liquid, slurry or emulsion under pressure into soil. So, this occupy available pores. So, injected fluids solidify, so that the permeability reduces, and materials used are so generally used materials are cement, asphalt, clay. So, this reduce water and contaminant movement, so that the plume will be stopped at particular locations. Then another technique is so called use of slurry walls. So, slurry walls are used to encapsulate an area to either prevent groundwater pollution or contaminated water. So, digging a trench around the area and then backfilling with impermeable material. So, this prevent the movement of plumes. So, like that say like as we discussed as the surface water control and capping and linears. So, this can be using sheet piling, grouting, slurry walls, etc. So, now say what we are discussing is groundwater pollution sources, then the mechanism of movement of the pollutant, and then how we can protect the groundwater systems or how we can control the pollutant movement. So, now once the groundwater system of the aquifer is polluted, then what we can do. So, that process is called groundwater pollution remediation. So, we are trying to remediate or we remove the contamination from the aquifer systems or from the groundwater system. But this is a quite very complex process, and it is also very expensive. So, once a groundwater is polluted, the question is how to restore or improve to acceptable standard. So, whether it is very depending upon the use, whether for irrigation or any other purpose, how we can get to the acceptable standard. So, for this say we have to study the system thoroughly. So, first we have to determine the distribution of pollution, then we have to design a remediation strategy. So, as I mentioned, once an aquifer is polluted, to make it to the actual original level is impossible task. But of course, we can do certain measures so that say the contamination say can be reduced or to certain level with the aquifer systems or the groundwater can be remediated. So, in this all this process, the first step is say we have to stop first once a contamination is identified or contaminant plume is identified. First step is we have to contain that pollution or containment of the plume, and then second one is say we have to go for remediation. So, containment is also very important as far as the plume movement we have to contain, otherwise again it will spread through the aquifer system. So, first step is containment, second one is the remediation. So, generally for groundwater pollution remediation is concerned, two types of technologies or techniques are used. First one is called on-site techniques and second one is called in situ techniques. So, on-site techniques means generally we will be pumping out the polluted water from the aquifer systems, and then we can treat it, and then either we can put it back to the aquifer systems or we can use it, or we can spill to the nearby surface water sources like lakes or rivers. Then second one is so called in situ techniques. So, here actually we are not pumping out the polluted water, we are doing say we are adding some say materials like for bioremediation or say air sparging or various techniques, where in situ there itself we are say where the hotspot or the contamination is there itself we are trying to remediate. So, that technique is called in situ techniques. So, as I mentioned here, as say on-site techniques, say we generally pump the polluted water, treat and recharge back to the aquifer systems. So, one of the most commonly used method is pump and treat. So, there we pump the polluted water and treat it, and then either use it or put it back. Then in situ techniques directly remediate the contaminated water in the aquifer itself. So, in situ technologies say actually it is being say we do not know the actual the total groundwater system or subsurface system. So, that way it is quite complex process. So, these in situ technologies are still under development. So, it requires say complete site characterization, but it is a very complex process and expensive. So, many technologies are under development as far as in situ technology is concerned. So, we will have an overview of some of the important techniques used either on site, which is so called pump and treat, and some of the in situ technologies. We will have a brief review in this lecture. So, as I mentioned, one of the most commonly used treatment technology is on-site technique of pump and treat. So, here what we do, the contaminant plume wherever it is there in the hotspot, we through boreholes or through wells we pump this polluted water out of the aquifer systems, and then we treat outside depending upon the contamination, and then we can either pump it recharge back to the aquifer system, or we can use it, or we can spill it to the nearby sources, surface water sources. So, the contaminated groundwater is captured, pumped, treated and re-infiltrated back. So, for effective installation accurately we have to determine the location of the plume. So, this plume location is very important. So, accordingly only we can design a pump and treat system. Then we have to determine the hydrological hydrogeological parameters of the aquifer, like hydraulic conductivity, porosity, then chemical properties of the plume. Then we have to design the capture systems. So, say by pumping itself, then installation of extraction and infiltration wells. So, if we are going to infiltrate back to the aquifer systems, we have to also design the infiltration wells. So, this pump and treat, as we discussed earlier, this is also a plume management, or we can also use to contain the plume at certain locations. So, as we discussed earlier. So, some of the advantages of this pump and treat or on-site technique include it is simple to operate and design is simple, but some of the limitations, this need long time, say depending upon the area and depending upon the contamination, it may requires many years to remediate an aquifer system. And then there is possibility to design failure. So, the wells are not located properly or the pumping rate is not proper, then the pump and treat may not become successful, then it is very expensive. And then say for example, volatile organic contaminants, this pump and treat may not be so effective. So, these are some of the limitations as far as the pump and treat is concerned. So, now let us look into some of the commonly used in situ technologies. So, first one is so called bioremediation. So, bioremediation, what we do, depending upon the contamination, depending upon the plume, we can identify certain microbial bacteria. So, this bacteria can be the activities of this bacteria can be enhanced within the aquifer system itself, so that the contamination is consumed by the bacteria, and then it will be converted into harmless products. So, microbial processes used to degrade or transform the contaminants to less toxic or non-toxic forms, mitigating or eliminating the contamination. So, as far as microbial processes are concerned, it can be either aerobic conditions where sufficient oxygen is available. So, sufficient oxygen presence microorganisms convert organic contaminants into carbon dioxide and water. So, this depends upon the microbial say cell mass within the system. So, we can inject oxygen so that the aerobic activities, aerobic conditions will be improved. And another one is anaerobic condition, where the say it is the say the microbial processes are enhanced without say oxygen. So, nutrients such as sulfates, nitrate are provided, and contaminants are converted to methane and other compounds. So, this is what is done in anaerobic conditions. So, this bioremediation can be either aerobic conditions or anaerobic conditions. So, say bioremediation say generally used for organic compounds, organic contamination. So, some of the important parameters say we have to identify whether the contamination or the plume which we consider, whether it is biodegradable, and then what is the phase of the distribution. Then we have to identify the soil type, then the properties of the aquifer. So, all these things are very important as far as the bioremediation, but this bioremediation is one of the cheapest techniques available as far as the groundwater pollution remediation is concerned. Only difficulty is that we have to identify for the given contamination or the plume, we have to identify what kind of microbial bacteria can be used to say for the remediation, and then how to enhance its activities within the aquifer systems. So, this is so called bioremediation. Then some other techniques like in situ flushing. Say for example, here what we do, we inject aqueous solution into a zone of contaminated soil or groundwater. So, down gradient we extract the polluted water, and then this water is treated and then it can be re-injected. So, this is the technique of in situ flushing. So, flushing solution can be simply water, or we can introduce certain chemicals within the water, so called surfactants or co-solvents. So, this may speed up the movement of the contamination to the pumping well. So, the co-solvents or surfactants can be also added within the systems. So, in situ flushing enhances the conventional pump and treat, say for example. So, that can be combined with the pump and treat. And so, this the success of the in situ flushing depends upon the site. So, like hydrogeology, contaminant nature, and then the aquifer thickness, aquifer materials, etc. So, the efficiency depends upon the solubility and mobility of the plume. Some of the advantages include acceleration, inside cleanup, broad range of contaminants can be dealt with the in situ flushing. Limitation include possibility of say further spreading. When we are putting the water or the surfactants, then there is a possibility that the contamination can further spread to the aquifer systems. So, these are some of the limitations as far as in situ flushing is concerned. Then another commonly used methodology is called air sparging. So, here what we do, we inject air or oxygen under pressure into saturated zone to volatilize the groundwater contaminants and to promote biodegradation in saturated or unsaturated soil by increasing subsurface concentration. So, generally this air sparging can be used for volatile organic contaminants. The volatilized vapor migrates through the water zone or the unsaturated zone, and these are collected by the vacuum pumps. So, sometimes this air sparging is also called biosparging, since when we introduce the air, the bioremediation process also will be enhanced within the systems. And then this air sparging can be used to remediate volatile or semi-volatile contaminants like petroleum products, BTEX, benzene, toluene, and that kind of pollutants, then chlorinated solvents, etc. Say this is very say effective in areas where more pervious areas, homogeneous soils and large saturated thickness, the air sparging is more effective. So, some of the advantages of the systems include a low maintenance in situ remediation, a minimum disturbance to the site. So, since this process, once it is set, it will keep on going for a long time without much interference, and remediation can be achieved in a reasonable time. Some of the limitations include not efficient for pollutants which form complexes with soil or not efficient in low permeable areas. So, mainly air sparging we can use for volatile organic contaminants. Then another commonly used in situ technique developed in Germany is called groundwater circulation wells. So, this is an in situ technique for volatile organic contaminants amenable to air stripping. Here what we do, say if this is the hot spot of the contamination plume and this is the aquifer systems. So, here there will be a pumping well, and through say here we create an artificial flow field that flushes and transform the contaminants from aqueous phase to gaseous phase. So, here we strip with air, and then there will be hydraulic gradient will be generated, and then these are the path lines shown, and here say the water is again taken back here and then it will be circulated. So, that is why it is called a groundwater circulation well. So, typical groundwater circulation system consists of single well or with two hydraulically separated or skinned sections as shown in this figure. So, pumping in the lower followed by air stripping and re-infiltration in the upper screen creates this recirculation pattern in aquifer systems. So, this is the typical pattern. So, pumping mechanism controls the circulation processes and then exchange of large pore volumes. So, continuous flushing, dissolution, diffusion and desorption takes place. So, this creates a complex 3D flow field, and the efficiency depends upon radius of influence of the well. So, this is the radius of influence of the well. And then well screen length, number of screens, etc. So, some of the advantages include less investment and operating cost, no extraction, no lowering of groundwater levels. Some of the limitations, it is not suitable in thin aquifer systems and not efficient in low permeable regions, and this methodology also used mainly for volatile organic contaminants. So, whatever we are discussing about the how to remediate once the groundwater is contaminated, to remediate the groundwater contamination, or how to remediate an aquifer systems. So, now say let us see some of the important transport processes taking place within aquifer or within surface water. So, these transport processes what we are discussing is common to surface water as well as the groundwater systems. So, the processes involved in transport of chemicals from say for example watersheds, say these processes are very complex, and the process can be either physical, chemical and biological. So, the physical, some of the important physical processes can be like convection, suspension and deposition, dispersion, diffusion, say tillage, etc., what is happening within the watershed. Then chemical process can be like sorption, ion exchange, crystallization, hydrolysis, oxidation, reduction, photochemical reactions, etc. And then the third one is the biological or biochemical processes. So, these are some of the important processes of happening, say as far as the movement of the contamination within surface water or the groundwater. So, let us look into some of the important details of these transport processes. So, as I mentioned, convection, say it is the transporting fluids carries the transporting fluids carries the constituents like either dissolved or suspended contamination. So, the water is the principal carrier. So, since the water is moving in surface water in a river or in an aquifer systems. So, when the water is moving, the contamination is taken with that. So, that is the process of convection. Then suspension and deposition means the process by which solid particles moved into and returned from water. So, it can be rainfall and overland flow. So, these are some of the major factors as far as suspension and deposition is concerned. So, the materials held in suspension depends on the turbulence of flow. Turbulence, say when the turbulence is reduced, the particle settles. Say for example, when rainfall takes place, the overland flow keep on, say the level can keep on increasing, and depending upon the velocity the turbulence can be generated, and the suspension, and say when the velocity comes down, the turbulence reduced. So, the particle settles or deposition takes place. Then another important transport process is so called dispersion. So, this is the result of irregular or unequal transport either in surface water or groundwater. So, eddies and other turbulence in streams, in canals or the rivers, and in porous media is concerned the pathways, since the soil matrix is packed in such a way that there is a sinusoidal movement within the soil matrix. So, that can be a reason of the dispersion. So, some constituents move ahead or lag behind. Then another one is diffusion process, transport process. So, net movement of constituent in response to concentration difference or gradient. So, this is the process of called diffusion. Then in watersheds, say tillage affects the chemical transport indirectly by modifying the water and sediment movement. So, tillage means the soil surface is changed, the pattern is changed by tilling. So, that can affect the movement. So, these are some of the physical processes which can take place as far as the transport is concerned either in surface water or groundwater. Now, chemical processes are concerned, say first one is sorption. So, this means the movement of a constituent between the solid and the solution phases. So, sorption can be either adsorption. So, this occurs when chemical leaves the solution and adheres to some solid, and it can be desorption, that means the reverse process. So, at equilibrium a balance between desorption or adsorption can take place. So, this is one of the important chemical process. Then ion exchanges. So, the exchange of an ion in a solution for an ion of similar charge on the surface of an oppositely charged solid. So, this is so called ion exchange. Then the transport process can be crystallization. So, when it occurs when concentration of a chemical in solution exceeds its solubility. So, then automatic crystallization starts, so that the concentration reduces. Then another important chemical process can be hydrolysis. So, this reaction of a chemical with water to form different compounds. So, this is the process called hydrolysis. So, this is also a transport mechanism, the chemical transport. Then oxidation and reduction. So, reactions occurs when one chemical loses an electron and is oxidized while another gains the electron and is reduced. So, these are some of the important transport process, chemical transport processes which can take place either in surface water or in the groundwater. Then some of the important processes like biochemical processes or biological processes. In biochemical processes, enzymes that various microorganism contains can accelerate reaction rates. Organic chemicals can be transformed into other chemicals by oxidation, reduction, hydrolysis and other reactions occurring in the microorganisms. So, similarly, various the biological processes like activities of bacteria or viruses can also change the transport phenomena what is happening within the surface water or groundwater. So, as we discussed as far as the water is concerned, either surface or groundwater, some of the chemical constituents can be sediments, salts, nutrients, pesticides, oxygen demanding materials, heavy metals, microorganisms, water, temperature, etc. So, these details we have seen in the last lecture. So, now based upon this say what we discussed in the last two lectures, now in the next lecture we will be discussing the water quality analysis and water quality modeling. With respect to this transport process which we discussed. in this lecture. So, now some of the important references used for today's lecture include say some of the website from say Central Pollution Control Board, Water Resource Ministry, Groundwater Board, and some of the textbooks like Free Sanctuary Groundwater and then guidelines for water quality management. Then some tutorial questions for today. Critically study the groundwater pollution problems in India, study various sources and causes. So, you can get the details from this CPCB or Water Resource Ministry website. Study the various measures that can be adopted to reduce the groundwater pollution in India. Then some self evaluation questions. Illustrate the groundwater quality issues on watershed scale. What are the important sources of groundwater pollution, what are the different source control strategies for groundwater pollution, describe the on-site groundwater pollution remediation, describe the in-situ groundwater circulation wells systems for groundwater pollution remediation. So, these questions you can easily answer by going through today's lecture. Then few assignment questions like describe the groundwater management systems for quantity and quality. Then discuss the various measures of groundwater protection and pollution control. What are the important techniques for groundwater pollution remediation? Describe the in situ groundwater pollution remediation. What are the various transport processes involved in pollutant movement in surface water and groundwater? So, all these questions you can answer by going through today's lecture. And finally, one unsolved problem. So, in your area, in your watershed, critically study the possible groundwater pollution problems, identify the possible causes of groundwater pollution such as point source or non-point sources, agricultural sources or industrial sources. Then study how this pollution problem can be controlled or what kind of remediation activities can be adopted wherever pollution problems are there. So, what we discussed today include the groundwater pollution sources, then pollution control and then remediation, and we also discussed about the transport processes taking place either in surface water or groundwater. So, in the next lecture we will be discussing about the water quality modeling, say how we can model either the pollutant movement in surface water or groundwater. Thank you.